Hey guys, welcome back. It's me, Alice Dallo again. I'm here to teach you about another thermodynamics chemistry problem from ChemWiki. It's problem number 41. It says NaCl is added to solution with Hg2 plus and Pb2 plus are both 1 molarity. For Hg2Cl2, Ksp is equal to 1.3 times 10 to the minus 8. For PbCl2, Ksp is equal to 1.6 times 10 to the minus 5. Feel free to pause or to rewind back to this equation because I will be referring to it because this problem has maybe about 4 or 5 steps. So hang up. In part A, it asks which precipitate will form first. So let's do Hg first. Let's write down the formulas for each of them. Hg2Cl2 goes to 2Hg2 plus 2Cl minus, both in aqueous solution. Ksp is equal to Cl minus squared Hg2 plus squared. So here, Q is equal to K. Now, since Ksp is equal to 1.3 times 10 to the minus 18th, we can set that equal to the corresponding concentrations. So we know that Hg2 plus and both Pb2 plus are 1 molar given from our original. So right now we can substitute Cl minus for 2x since there are 2 of them. And if we were to construct, say, a hypothetical ice table, we would add 2x to both the products since there are 2 molecules, 2 moles. So here we would set 1.3 times 10 to the minus 18th is equal to 2x and then quantity squared times the 1 molar. And simplifying, we would get x is equal to 5.7 times 10 to the negative 10th molar. Doing the same for Pb, we would get x is equal to 0.002 molar. Now remember, for precipitation, Q is greater than K. Our objective of finding which precipitate will form first is which one has the lowest Cl minus concentration, because it would take less of Cl to actually form. So in this case, Hg2 plus would require less Cl to reach precipitation, so it would precipitate first. For part B, it asks which concentration of Cl minus is required for the second cation to begin to precipitate. Well, we found that in part A to get our results. So we know that the concentration of Cl minus is equal to 0.002 molar. For part C, it asks what concentration of the first cation precipitate remains in the solution at the point at which the second cation begins precipitating. So first, let's set our x for Hg. So we have 5.7 times 10 to the minus 10th. And then we would set that equal to x times the concentration of the Pb, which is 0.002 molar. Solving, we would get x equal to 2.85 times 10 to the negative 7th concentration for Hg2 plus. For part D, the last and final step, it asks, can Pb2 plus and Hg2 plus be effectively separated by fractional precipitation of their Cl minus concentrations? Well, fractional precipitation determines which ions are present in a solution with respect to different solubilities. In addition, it often separates elements with similar solubility properties. So here we could take what we found in part C and divide it by the concentration, 1 molar, and then multiply it by 100 because fractional is usually out of 100%. And we get 2.85 times 10 to the negative 7th. So we can say that Hg2 plus precipitates away and can be separated between Pb and Hg, both 2 plus.